Hi everyone. Today we're going to study about polynomial, the types of polynomial, terms, degree of a term, and degree of polynomial. First, let us define polynomial. Polynomial is an algebraic expression involving only the operations of addition, subtraction, multiplication, and raising to natural number powers on variables and constants. Example, 2x plus 5. Another example is x squared minus 4xy plus 2y squared. Third example, 9w. Fourth example, x cubed plus 3x squared minus 5x plus 2. There is a note here that in a polynomial, a variable cannot appear on three places. The first is in a denominator. So this is an example of not a polynomial, this x over 2x plus 1, because there is an x in the denominator. So this example here, 3x squared plus 1 all over 5 plus the fraction x plus 2 over 4 minus the constant 5. So this is a polynomial. It is true that there is a fraction, but in the denominator there is no variable. So this is a polynomial. So a variable cannot appear as an exponent. So this is another example. 10 raised to x plus 1. So in the exponent there is a variable x. So this is not a polynomial. So another case, a variable cannot appear within a radical, or we can say that as a radicand. So this example here, the square root of y minus 6. So there is a variable y in the radicand, or I can say that there is a variable inside the radical symbol. So this is not a polynomial. Here is an example of a polynomial. See here, the square root of 3 as a coefficient of x. See the radical, it is only for the number 3 and not the x. So there is no variable inside the radical symbol. Plus the fraction 5x over square root of 7. So in this term there is a fraction, but there is no variable in the denominator. So still this is a valid form of a polynomial. And then plus the whole number 1. This expression here is a polynomial. Let's go to term. As defined, each member of a polynomial is called term. I have here an example of a polynomial with three terms. So this is x squared minus 4xy plus 2y squared. So we may say that the first term is x squared, the second term is negative 4xy, and the third term is 2y squared. In a term, the number is called numerical coefficient, and the variable or variables is called literal coefficient. I will start with the third term. So in here, number 2 is the numerical coefficient, and the y squared is the literal coefficient. In the second term, the numerical coefficient is negative 4. The literal coefficient is xy. In the first term, the literal coefficient is x squared. There is no number here. For a term without any number, it is understood to have a numerical coefficient of 1 here. So the numerical coefficient is 1 for the first term. Let's go now to types of polynomial. The first is monomial. By the word mono, it means there is one term in that polynomial. Our example here is 2x. There is only one term. The second is binomial. By the word bi, it denotes two terms. Example is 5y plus z. Third type is trinomial. The word tri or the prefix tri denotes 3. Example is 3w squared plus 5w minus 1. For polynomial with 4 terms or more, we use the general term of it as this polynomial. So as an example, we have x cubed plus 3x squared minus 5x plus 2. Let's go now to degree of a term. As defined, degree of a term refers to the exponent of each variable. In case of multiple variables in a term, degree is the sum of all exponents of all the variables. Example, 3x raised to 5, the degree is 5, degree of 5. Because the exponent of x here is 5. Another example, 2x y cubed, the degree is 4. Because we have two variables here, so we are adding the exponents here, x with exponent 1, the y with exponent 3, so we add the 1 and the 3, so the degree is 4. Another example, p squared q raised to 5 r, degree of 8, we are adding all the powers, 2 plus 5 plus 1 equals 8. So the degree of this term is 8. Another example, 3y, obviously the degree is 1 because of this exponent here. A constant of negative 2, the degree is 0. As a rule, the degree of non-zero constant is 0. Now, what about 0? There is no degree for the number 0. Let's go now to the degree of a polynomial. As defined, degree of a polynomial is the highest degree of the term in a polynomial. Let's have one example, 3w squared plus 5w minus 1. Let us identify the degree of each term. In the first term, the degree is 2. Second term, the degree is 1. The third term, the degree is 0. So the degree is 2 because the highest degree is 2, and that is in the first term. Let's have the second example, 10x cubed plus 3x squared y squared minus 5xy plus 2y cubed. Let us identify the degree of each term. In the first term, the degree is 3. In the second term, the degree is 4. Third term, degree is 2. Fourth term, the degree is 3. So the highest is in the second, and that is degree of 4. So the degree of this polynomial is 4. Third example, x raised to 7 plus x squared y squared minus xy plus y raised to 8. Let us identify the degree of each term. In the first term, degree is 7. Second term, the degree is 4. Third term, the degree is 2. The fourth term, degree is 8. So our highest is 8, which is in the fourth term. So it means the degree of this polynomial is 8. Hi everyone, today we're going to study addition of polynomials. First, let us define like terms. Like terms are terms with same literal coefficient, otherwise unlike terms. Let's have some examples here. I have here 4 terms: 2x, negative 5x, x, 3/7 of x. As I observed, the literal coefficients for all these 4 terms are x. So they have common literal coefficient. So these 4 terms here are like terms. Another example, I have 3 terms here. The first is 5a cubed b squared c. Second, negative a cubed b squared c. The third, the square root of 10 a cubed b squared c. Now, observing the literal coefficients of all these terms, it is common, and that is the a cubed b squared c. So we don't care about the numerical values or the numerical coefficient. Since they have the same literal coefficient, they are like terms. Third example, 10a cubed b squared. Second is 10a squared b cubed. In here, they have the same variables a and b. However, the exponents are different. In the first term, the power is 3. In the second term, the power of a is 2. While here, the b has an exponent of 2. In here, the exponent of b is 3. So they have different literal coefficient. So when we say the same literal coefficient, even the powers must be same. So in this example, for this group of terms, these are unlike terms. Fourth example, I have here 2 terms, 2a cubed b squared c. The second is 5a cubed b squared. So in the first term here, I have 3 variables a, b, c. In the second term, I have only 2 variables a and b. While it is true that the exponents for the a and b are same, but in the second term, the variable c is missing. So in this case, this is an example of unlike terms. Let's go now to addition of polynomials. Let's begin with addition of monomials that are like terms. The rule is given to add the numerical coefficients and copy the common literal coefficient. Let's see an example. 3xy plus 2xy plus xy. So we are sure that this group of terms are like So we can add the numerical coefficients. I collected the 3, the 2, and the 1. The 1 is the coefficient of the xy. And then for the literal coefficient, we simply copy that same and common literal coefficient. So 3 plus 2 plus 1 gives us 6, and the xy, the literal coefficient, is simply affixed. Second example, 10xy square z cubed plus 4xy square z cubed. Again, looking at the literal coefficients, we are sure that these two are like terms, so we can now add the numerical coefficient. So the 10 plus 4, and then we copy that common literal coefficient, the xy square z cubed. So the final answer is 14xy square z cubed. Third example, 4xy square plus 2x square y. Looking at the literal coefficients, it seems there is a problem here. In here, xy are there, but the coefficients as compared with the second literal coefficients are not same. Here is x with exponent 1. Here there is an x with exponent 2. For the y, here is exponent 2. Here is with exponent 1. So we can see here that we can conclude that these two terms are dissimilar. And it says dissimilar terms cannot be combined. So when we are required to put the answer here, we simply copy that same problem. So our answer here is, I simply copied the 4xy square plus 2x square y. Let's go now to the addition of polynomials. The rule says combine like terms. Example 1. Simplify. There is a group of polynomial here, 6x squared plus 2x plus 3, plus the second group, 4x squared plus 5x minus 1. So the rule says let us combine like terms. So the 6x squared is combined to the 4x squared. We will get this 10x squared. Next is the 2x and another 5x on the other group. We can put them together. So we add the numerical coefficients. 2 plus 5 gives us 7. And we copy the x. And for the constants, here is 3. In the second group, there is negative 1. So 3 combined to the negative 1 will have the positive 2. So the final answer is 10x squared plus 7x plus 2. Let's see second example. Sometimes problem will come to you like this. Find the sum of the polynomial 2x squared minus 3x plus 5 and the polynomial 5x squared plus 4. We can rewrite this problem like this. Put a grouping symbol to the first group, list here, and then put a plus sign. Then take the second group, put a grouping symbol, and place it next to the first group. And then we will go now to combining like terms. So here we have 2x squared. Here there is 5x squared. We can write the answer as 7x squared. And for the negative 3x, there is no term in the other group with the x as literal coefficient. So the negative 3x directly we can place in the sum. Make sure that you don't forget to include that negative 3x. And for the constants, the 5 plus 4 will give us 9. So the final answer is 7x squared minus 3x plus 9. Example 3. The three sides of a triangle is measured at 3x minus 2, x plus 1, and 2x plus 7. Find the perimeter of the triangle. First, we should know that perimeter is the sum of all sides. So we're going to add the sides of the triangle. So P, that stands for perimeter. So I collected the 3x minus 2, that is the first side, x plus 1, that is the second side, the 2x plus 7, that is the third side. And then we simply collect the like terms, the 3x, the x, and the 2x. We combine them together, we'll get the 6x, and the constants negative 2, the positive 1, the positive 7. We will get a positive 6. So 6x plus 6. This is our final answer. This is the perimeter of the triangle. Hi everyone. Today we will study subtraction of polynomials. First, let us review. Suppose there is an equation a minus b equals c. Naming the parts of these three numbers here, the first number representing a is called minuend. The second number b is called the subtrahend, and the result of this subtraction is called difference. Now let us go to subtraction of polynomials, starting with the first part, subtraction of monomials of like terms, meaning these are terms with the same literal coefficient. The rule is mentally change the sign of the subtrahend, then proceed to the rule of addition. To illustrate, suppose we have a minus b. What we will do, in here the b is positive, we will put the minus sign with a b, and then the operation becomes addition here. So it means to say, in relation with our rule here, in subtraction of monomials, suppose the b is positive, showing this as minus b means we should change the positive into negative. On the other hand, if your b is negative, we're going to change the negative into positive. And then we will use the rule of addition to combine the a and this b with a new sign, and we will get this variable c, or the difference of c. So let's have an example 1, 5x minus 3x. So for the 5x, that is the minuend, we simply copy that here. Look at the 3x here, this is our subtrahend, so the 3x becomes negative 3x, and the minus sign becomes plus. And then we will apply the rule of addition. Since we have two terms here with opposite sign, we're going to subtract the coefficients, and then we will affix the sign of that coefficient with a greater absolute value. And then for the variable, we will copy the common variable or the common literal coefficient. So the answer is 2x. The positive 5 plus a negative 3 will give us positive 2, and the variable x is copied. So the final answer is 2x. Example 2. 5xy minus a negative 3xy. So we will change the sign of the subtrahend. From negative it becomes positive, and the sign becomes addition. So the minuend is simply copied here. Then we will now combine the 5xy plus the 3xy. So we have the final answer as 8xy. Example 3. Negative 10y minus a negative 2xy. So again, the second term is our subtrahend, so we're going to change the sign. From negative, it becomes positive, and then the operation becomes addition. However, we can observe here that the first term and the second term are not like terms. Here, the literal coefficient is y, and on the second term, the literal coefficient is xy. So, as a rule, unlike terms cannot be combined. So for our final answer, we will simply copy all these terms. So negative 10y is here now, and then plus the 2xy. So final answer is negative 10y plus 2xy. Let's go now to subtraction of polynomials. The rule is we change the sign of all terms of the subtrahend, then add like terms. Let's see one example. Perform the operation. We have two polynomials here. 4x squared minus 2x minus 7 is our first polynomial, minus the second polynomial, x squared plus 5x minus 3. So the second group is our subtrahend. We're going to remove the grouping symbol for all these two groups. And then for the second group, we're going to change the sign. So the first three terms here are the terms of our first polynomial. Then the second polynomial, we will change the sign of all the terms. The x squared here is positive. In here it becomes negative. The 5x is positive. Here it becomes negative. The negative 3 becomes positive 3. And then we will combine like terms, or we will add like terms. We have here 4x squared. There is a negative x squared here, so we can combine these two. We have 3x squared, and then the negative 2x. There is a negative 5x here. We will combine these two. We will get the negative 7x, and for the constants, negative 7, and there is a positive 3. So it is negative 4. So our final answer is 3x squared minus 7x minus 4. Let's have another example. Subtract 5x squared plus x minus 4 from the 4x squared minus 6x plus 7. So there is a little analysis of the position of the polynomials here. We know that we are putting a minus b in a normal operation of subtraction. But based on the manner of the problem is written, the second polynomial here is considered to be the a, and this first polynomial here is our b. So it means to say we're going to put the second polynomial first, that will be our minuend, followed by our subtrahend. And then, as a rule, we're going to remove the grouping symbol, but we will change the sign of all the terms of the second polynomial. See here, the 4x squared minus 6x plus 7 are simply copied here without the grouping symbol. Then for the second polynomial, the 5x squared is positive here, it becomes negative. The plus x becomes negative x, the negative 4 becomes positive 4. And from here, we will combine similar terms. The 4x squared and the negative 5x squared, we can add together. We will get the negative x squared, negative 6x and negative x. With both negatives, we will combine them. It becomes negative 7x. And for our constants, the 7 and the 4 becomes 11. So the final answer is negative x squared minus 7x plus 11. Let's have example 3. 2x cubed minus 5x plus 1 minus the quantity 3x squared minus 5x minus 6. So we will follow our rule. The second polynomial is our subtrahend. We will change the sign of all the terms of our subtrahend. So 2x cubed is here, minus 5x plus 1. And then the 3x squared becomes negative 3x squared. The negative 5x becomes positive 5x. The negative 6 becomes positive 6. And then we will collect and combine like terms. The highest power here is the cube. So it seems there is no other variable with cube. So only this one, the 2x cubed. We will simply copy this. And for the followed by this negative 3x squared, there's no other term with a variable x squared. So we will put this negative 3x squared in the final answer also. For the negative 5x, and there is a positive 5x here, it is cancelled. Then for the constants, it is 1 plus 6. It becomes 7. So our final answer is 2x cubed minus 3x squared plus 7. Thank you for watching. See you again next time. Hi everyone. Today we will study multiplication of polynomials. Let's begin with multiplication of monomials. The rule is multiply the numerical coefficients and multiply the literal coefficients or the variables following the laws of exponent. Let's see the first example, 4x cubed times 3x raised to 5. We understand this dot here denotes multiplication. So we're going to multiply these two terms. So the rule says we're going to multiply the numbers. So that is 4 times 3, we will get 12. And the x cubed multiplied to the x raised to 5, we will add exponents. So we have x raised to 8. So the final answer here is 12x raised to 8. Second example, 2x raised to 4y cubed times the negative 5x squared y. So the parenthesis here denotes multiplication. So we will multiply the numbers. The 2 times the negative 5, we will get negative 10. The x raised to 4 multiplied to the x square, we will get the x raised to 6. The y cube multiplied to y. So there is a exponent 1. So 3 plus the 1 equals the exponent 4. So y raised to 4. Our final answer is negative 10, x raised to 6, y raised to 4. Example 3. Sometimes problem will come like this. Find the product of negative 3x squared y cubed z raised to 4 and the term negative 2x raised to 4z. Let us rewrite the problem into this form. So using the parenthesis symbol to denote multiplication. So let's begin the multiplication. Let's start with the numbers. The negative 3 multiplied to the negative 2 will get a positive 6. The x squared multiplied to the x raised to 4, we will get this x raised to 6. The y cubed, there's no variable y on the other term. We will just copy the y cubed. The z raised to 4 multiplied to the z with exponent 1. So we add the exponent, so 4 plus 1 becomes 5. Z raised to 5. So our final answer is 6, x raised to 6, y cubed, z raised to 5. Example 4, when we multiply negative 5a by the term 2b. In here we can see that there is no common variable. So what we'll do, first we will multiply the numbers. Negative 5 multiplied by 2, we will get the negative 10, and the variables a and b, we'll just put them together in the final answer. So our final answer here is negative 10 ab. Example 5, the terms are 2/3 x cubed 5/7 x squared. So we multiply the numbers. In this case, we have fractions. So the numerator multiplied to numerator, denominator multiplied to denominator. So we have the 2 times 5 becomes 10, 3 times 7 is 21. For the x cubed times x squared, we will get the x raised to 5. So the final answer, 10/21, x raised to 5. Let's go now to multiplication of monomial and polynomial. Rule says multiply the monomial to all terms of the polynomial. Let's have example 1. The 3x is multiplied to the polynomial x squared plus 2x minus 10. So what we'll do, this 3x, we will multiply to each term of the trinomial here. Let's begin with the 3x multiplied to x squared. We will get this 3x cubed. Then 3x multiplied by 2x, we will get the 6x squared. The third, 3x multiplied by negative 10, we will get this negative 30x. So our final answer, 3x cubed plus 6x squared minus 30x. Example 2, the polynomial and the monomial can be interchanged in position. So in here we have the polynomial x squared y cubed plus 2x plus 3y times the monomial 5xy. So the same procedure, each term of this polynomial will be multiplied to the monomial. Let's start with the x squared y cubed times 5xy. We will get the 5x cubed y raised to 4. As we see here, the x squared with the x with exponent 1, we'll get x cubed. With the y cubed multiplied to the y with power 1, we'll have the y raised to 4. Next is the 2x multiplied to the 5xy. The numbers becomes 10. 2 times 5 is 10. For the x and x becomes x squared. The y, there is no y in the term here, so we'll just copy the y in the product. So 10x squared y. The next is the 3y multiplied to the 5xy. We'll get 15. There is no x on the first term here, so we have the x, we simply copy, and then the y times y, we'll get the y squared. So our final answer, 5x cubed y raised to 4 plus 10x squared y plus 15x y squared. Let's go now to multiplication of polynomials. The rule says multiply each term of the first factor polynomial, that is the multiplicand, to each term of the second factor polynomial, that is the multiplier. Then we add like terms, if any. Example 1, 3x plus 5 multiplied by 2x minus 1. So what we'll do, the first term 3x of the first group will be multiplied to the terms of the other group. So the 3x is multiplied to 2x, we'll get the 6x squared. 3x multiplied by negative 1, we'll get the negative 3x. The next is the 5, the second term of the first group, we will multiply to all terms of the second group. So 5 times 2x, you will get the 10x, and 5 times negative 1, we will get the negative 5. And then we will see if there is a like terms. As we see here, the negative 3x and the 10x are like terms, so we can add them. So the negative 3x plus 10x becomes positive 7x, and then the final answer is this 6x squared plus 7x minus 5. Example 2, 2x plus 1 multiplied by the x squared plus 3x plus 4. So what we'll do, the 2x, the first term of the first group, we will multiply to all the terms of the other group. So the 2x multiplied to x squared, we will get the 2x cubed. 2x times 3x, you'll get the 6x squared. 2x times 4, you'll get the plus 8x or positive 8x. The next is this one here, we will multiply also to all the terms of the other group. So 1 times x squared, we will get the x squared. 1 times the positive 3x, here is positive 3x, and 1 times the positive 4, we will get here plus 4. And then we will observe for some like terms. As we see here, the 6x squared and the x squared are like terms. Also, the 8x and the 3x are all like terms. So we can combine those like terms. So the 6x squared and the x squared, both positive, becomes 7x squared. The 8x and the 3x, also both positive, is equal to 11x. So we just bring down the 2x cubed, we bring down the constant 4. So the final answer here is 2x cubed plus 7x squared plus 11x plus 4. Let's go to example 3, a plus b multiplied to the c plus d. So the a is multiplied to the terms of the second group, A times C will give AC, then A times D will get the AD. Next is the B multiplied to the terms of the other group. So B times C is BC, then B times D is BD. So our final answer is this AC plus AD plus BC plus BD. Thank you for watching. See you again next time. Hi everyone. Today we're going to study division of polynomials. Here are the steps. Number 1. Arrange the terms of the dividend and the divisor in decreasing order of their degrees. Step 2. To obtain the first term of the quotient, divide the highest degree term of the dividend by the highest degree term of the divisor. Then, carry out the division process. Step 3. Now, to obtain the second term of the quotient, divide the highest degree term of the new dividend by the highest degree term of the divisor. Again, carry out the division process. Step 4. Stop the process when the degree of remainder is less than the degree of the divisor. Let's have this division algorithm for polynomials. It says, if p of x and g of x are any two polynomials, with g of x not equal to 0, then we can find polynomials q of x and r of x, such that p of x equals g of x times q of x plus r of x, where r of x equals 0 or degree of r of x is less than degree of g of x. Example 1. Divide 3x cubed plus x squared plus 2x plus 5 by 1 plus 2x plus x squared. The first step is to arrange the terms of the dividend and the divisor in the decreasing order of their degrees. After that, we put them in the division box. So the dividend is here, 3x cubed plus x squared plus 2x plus 5. For the divisor, we have this x squared plus 2x plus 1. Let's begin our division process. This 3x cubed we will divide by x squared. The answer is 3x. We will put our answer above the 3x cubed. Next is, we multiply this 3x to each of the terms of our divisor. So 3x times x squared will be 3x cubed. 3x times 2x is 6x squared. 3x times positive 1 is 3x. Then we subtract. When we subtract, we know that we need to change the sign of the terms of the subtrahend. Meaning, this is positive now becomes negative. From positive becomes negative. From positive becomes negative. Then we add. This 3x cubed and negative 3x cubed will cancel each other. So positive x squared minus 6x squared, we have now this negative 5x squared. Positive 2x and minus 3x becomes negative x. Then we bring down the positive 5. This is now our new dividend. This negative 5x squared we now divide by x squared. The answer is negative 5. Then we write the answer in here. Next, we multiply negative 5 to each of the terms of our divisor. And the answer we will place down here. So negative 5 times x squared is negative 5x squared. Negative 5 times 2x is negative 10x. Negative 5 times 1 is negative 5. Then we subtract. We will change the signs of the terms of our subtrahend. This negative 5x squared becomes positive. The negative becomes positive. This negative 5 becomes positive. Then we add. This negative 5x squared and positive 5x squared will cancel out. Then this negative x plus the positive 10x is 9x. Positive 5 plus 5 is now plus 10. From here, we stopped because our new dividend here, 9x plus 10, has lesser degree than our divisor. So, the quotient is 3x minus 5 and the remainder is 9x plus 10. Example 2. Divide 3x squared minus x cubed minus 3x plus 5 by x minus 1 minus x squared and verify the division algorithm. First, we arrange the terms of the dividend and the divisor in the decreasing order of their degrees. After that, we put them in the division box. So it becomes like this. Our dividend now is negative x cubed plus 3x squared minus 3x plus 5. And the divisor, negative x squared plus x minus 1. Let's begin our division. The first term here, negative x cubed, is divided by the negative x squared. The answer is x, so we write the answer above the negative x cubed. Next, we multiply this x to each of the terms of the divisor. The answer is negative x cubed plus x squared minus x. Then we subtract. We change the sign of the terms of the subtrahend. This negative becomes positive. The positive becomes negative. Negative becomes positive. Then we add. Negative x cubed plus positive x cubed cancels out. Positive 3x squared minus x squared is 2x squared. Negative 3x plus x is negative 2x. Then we bring down plus 5. This is now our new dividend. So this 2x squared we divide by negative x squared. The answer is negative 2. Next, we multiply negative 2 to each of the terms of our divisor. So we have this 2x squared minus 2x plus 2. Then we subtract. Again, we change the sign of the terms of the subtrahend. This positive becomes negative, negative becomes positive, positive becomes negative. Then we add. The 2x squared plus negative 2x squared will cancel out. Negative 2x plus the positive 2x will cancel out also. Positive 5 minus 2, the answer is positive 3. This is the new dividend, but we stop here because the degree of the dividend or the new dividend is less than the degree of the divisor. Therefore, the quotient is this x minus 2 and the remainder is 3. Now we check or verify the division algorithm. That is, the dividend is equal to divisor times the quotient plus the remainder. When we substitute the corresponding values, we have this divisor x minus 1 minus x squared. The quotient is x minus 2 plus the remainder plus 3. When we simplify the product of divisor and quotient, we will have this polynomial x squared minus 2x minus x plus 2 minus x cubed plus 2x squared, then the remainder plus 3. Let us combine the like terms inside the grouping symbol. This x squared combined with 2x squared. So we have 3x squared. Negative 2x and then negative x becomes negative 3x. Then we have this plus 2. Then we have the negative x cubed. Again, we copy the remainder plus 3 in here. Let us now remove the grouping symbol here and combine the constant 2 with the remainder. We will have this 3x squared minus x cubed minus 3x plus 5. And this polynomial is equal to our dividend. Example 3. Find the zeros of x cubed minus 3x squared minus x plus 3 if one of its zeros is 1. Since 1 is a zero of the polynomial, then x minus 1 is a factor of x cubed minus 3x squared minus x plus 3. Thus, this cubic polynomial here can be divided by x minus 1. So, we write our dividend inside the division box, x minus 1 outside. This is our divisor. Let's begin the division. X cubed divided by x. The answer is x squared. X squared times x, we have x cubed. X squared times negative 1, we have negative x squared. Then we subtract. We change the sign of the terms of the subtrahend. This x cubed becomes negative. This negative becomes positive. Then we add. X cubed plus negative x cubed cancel out. Negative 3x squared plus x squared. We have this negative 2x squared. Then we bring down this negative x. This is our new dividend. We divide negative 2x squared by x. The answer is negative 2x. The negative 2x we multiply to each of the terms of our divisor. So we will have this negative 2x squared, then plus 2x. Then we subtract. We change the sign again of the terms of the subtrahend. The negative becomes positive, the positive becomes negative. Then we proceed to addition. The negative 2x squared plus 2x squared will cancel out. The negative x plus the negative 2x, we will get the negative 3x. Then we bring down the plus 3. Now we divide negative 3x by x. The answer is negative 3. Then we multiply negative 3 to each of the terms of the divisor. We write the answer down here. So we have negative 3x plus 3. Then we subtract. Again, we change the sign of the terms of the subtrahend. Then we add. Negative 3x plus 3x will cancel out. Positive 3 plus the negative 3 is 0. From here, we stop because this is already 0. Or we say that the degree of the dividend is less than the degree of divisor. So the quotient is x squared minus 2x minus 3. And the remainder is 0. Actually, no need to mention the remainder if it is 0. By division algorithm, we can write this x cubed minus 3x squared minus x plus 3 equals x minus 1 times the quantity x squared minus 2x minus 3. Next is, let us factorize the trinomial here, and the answer we will get and write here. So the dividend is equal to x minus 1 times the factors of x squared minus 2x minus 3. which are x minus 3 and x plus 1. We equate each factor to 0 and solve for x. So we have this x minus 1 equals 0, which is the given, x minus 3 equals 0 coming from here, and the x plus 1 equals 0. When we solve for the x, we have x equals 1, here x equals 3, here x equals negative 1. These are the zeros of our polynomial. Example 4. Find all zeros of 2x raised to 4 minus 3x cubed minus 3x squared plus 6x minus 2 if two of its zeros are square root of 2 and negative square root of 2. Since square root of 2 and negative square root of 2 are zeros of the polynomial, then we can write x minus square root of 2 times x plus square root of 2. When we multiply this, we will get x squared minus 2. This binomial here is a factor of the given polynomial. And that means we can divide this polynomial by x squared minus 2. So let us put them in division box. The dividend is inside. Our x squared minus 2 is the divisor. Let us proceed to division. 2x power 4 divided by x squared. 2x squared. Then we multiply 2x squared to each of the terms of the divisor. So we have this 2x power 4 and then negative 4x squared. We place the negative 4x squared below this negative 3x squared. Then we subtract. We will change the sign of the terms of the subtrahend. So this is now negative and this is now positive. The 2x power 4 plus negative 2x power 4 will cancel out. Then we combine this negative 3x squared plus the positive 4x squared. We will have x squared. Then we bring down the negative 3x cubed, also the 6x minus 2. This is now the new dividend. This negative 3x cubed divided by x squared. The answer is negative 3x. This negative 3x we multiply to each of the terms of the divisor. The answer is negative 3x cubed and positive 6x. Let us subtract. Let us change the sign of the terms of the subtrahend. This negative becomes positive. The positive becomes negative. Then we add negative 3x cubed plus 3x cubed, cancel. Positive 6x plus negative 6x also cancel out. Now we bring down x squared and the negative 2. We divide x squared by x squared. The answer is plus 1. This 1 we multiply to each of the terms of our divisor. The answer is x squared minus 2. When we subtract, the answer will be 0. From here we stop because the remainder is 0, or we say that the degree of remainder is less than degree of divisor. So by division algorithm, we can write the dividend is equal to the x squared minus 2, this is the divisor, times our quotient 2x squared minus 3x plus 1. The remainder, no need to write. The next step here, we need to factorize this trinomial, the 2x squared minus 3x plus 1. When we factorize, first we write it here. We're going to split the middle term into two terms in such a way that the product must be 2x squared. We got this value when we multiply this 2x squared by the constant 1. So we write it like this: 2x squared minus 2x minus x plus 1. The negative 3x is split into negative 2x and negative x. When we multiply negative 2x by negative x, the answer is positive 2x squared. Then we group the first two terms here and the last two terms. In the first two terms, there is a common factor, and that common is 2x. When we factor it out, what remains in the first group is x minus 1. In the second group, the common is the negative sign. When we pull it out, what remains in the second group is the x minus 1. On this line, we have now two big groups, and we can observe that there is a common binomial. We can put that common outside. So it becomes like this. The x minus 1, which is the common, is factored out. Then what remains here is the 2x, and in here, minus 1. So these are the factors of our trinomial here. Then we write again our division algorithm. The given polynomial or the dividend is now equal to like this. We show now this x minus square root of 2 and the x plus square root of 2 representing the x squared minus 2. Then we write this x minus 1, also the 2x minus 1. We equate each factor to 0 and solve for x. Therefore, we will have like this. This x equals square root of 2 coming from this. The x equals negative square root of 2 coming from this. Actually, these are the given here. Now, for x minus 1, it becomes x equals 1. The x equals 1/2 comes from 2x minus 1. These are the zeros of the polynomial. Hi everyone. Today we will study special products, and we will discuss the sum and difference of two terms. And another form of special product is the square of binomial. First, let us define special products. Special products are simply special cases of multiplying certain types of polynomials together. Let's begin with our first special product, and that is the sum and difference of two terms. And the pattern is like this. We have x plus y multiplied by the x minus y. So the x, or the first term of the first group, is the same with the first term of the second group. The second term of the first group is the same with the second term of the second group. The only difference here is the sign. This is plus, the other is minus. Or sometimes we can put the minus sign here and the plus sign on the second group. So according to the rule, the answer here is the first term, that is x, we will put a square and then minus, and that is always minus. The second term, y, will be squared. Let's have a quick multiplication for this x plus y times x minus y. So we have to multiply x by x, we will get the x squared. We multiply x by the negative y, we will get this negative xy. The y multiplied to x, we will get the yx, or we can put xy to show that the similarity with the other term here. So we'll put xy, and y multiplied by negative y, we will get the negative y squared. Then we can see that we can cancel the negative xy and the positive xy here. So copying the remaining terms, x squared and then minus y squared. And we can see that this product is the same with our formula here. So now we are ready to take some examples. Example 1, x plus 5 multiplied by x minus 5. So we will use our formula. We will take the first term x and then we will square that. Then minus, we will get the second term 5 and we will square that. And then we will just simplify each term to be x squared minus 25. So this is our final answer. Let's have example 2, 2x minus 10 times 2x plus 10. So this time the negative sign comes first and the plus sign is in the second polynomial. So the same idea, we can use this formula. So what we'll do, the 2x, that is the first term, we will put it here and square that. And then minus the 10, the second term, put it here and then square that. And we will simplify each term. So the 2x all raised to 2 becomes 4x squared. Then minus the 10 squared is 100. So this is our final answer. Example 3, 4x plus 7y squared multiplied by 4x minus 7y squared. The first term 4x is squared, then minus the 7y squared is again squared. So we simplify 4x all raised to 2, it becomes 16x squared, and then minus the 7y squared is raised to 2, so it becomes 49y raised to 4. So this is our final answer. Let's go now to the square of binomial, and this is of the form, the first part is x plus y raised to 2. So this is the sum of two terms and raised to 2. In the book, we write the answer it to be x squared plus 2xy plus y squared. It means to say, if we're going to square a binomial or the sum of two terms, we expect 3 terms in the final answer. So let us examine one by one. The first term here is simply the square of this x. So you see here it is x squared. The middle term, the constant 2 will always be there. And then the xy here is actually the product of these two terms, x times y. So this is xy. And the y square here is the square of this y, the second term of our binomial. So that is y squared. So again, when we square a binomial, the answer will be 3 terms, and this answer is x squared plus 2xy plus y squared. So let's have a quick multiplication of this x plus y all raised to 2, this square of binomial here. So what we'll do, first, we are going to expand the exponent. The power 2 simply means we have x plus y times x plus y. And then we will do the long method of multiplication. One by one, we will multiply the x with the x. We will get x squared. X multiplied by y, we will get the xy. And then the y multiplied to x, we will get the yx, or we can write it also as xy. And the y multiplied by y, we will get the y squared. There are like terms that we can combine. xy, another xy, we'll put 2xy. So the final answer, x squared plus 2xy plus y squared. We can see that this product here is the same with our special product on top here. It means to say, we can now use this formula in some of our examples. So example 1, the a plus 3 is raised to 2. So in our answer, we expect 3 terms represented by these 3 blanks. So the first is the a is squared. The middle term, the a and the 3 are multiplied here with the 2 constant. We will not forget the 2. And that is for the middle term. And the last blank is for the 3 to be squared here. And then we will simplify each term. So the a raised to 2 becomes a squared. The middle term, 2 times a times 3 becomes 6a. And the 3 squared is 9. So the final answer is a squared plus 6a plus 9. Example 2, 5x plus 2y all raised to 2. So for our 3 terms, directly I put here. So the 5x comes from the first term and it is squared. The middle term, the times 2, the constant 2 is here. And then I copy the 2 terms, the 5x and the 2y are here. And the last term will be the 2y must be squared. And then simplify each term. So the 5x power 2 becomes 25x squared. The middle term, 2 times 5 is 10, times 2 is 20, and the xy will just include. So the middle term is 20xy, plus the last term, the 2y is squared. It's now equal to 4y squared. Let's go to the second part of the square of binomial when we have a difference of 2 terms and it is squared. So x minus y all raised to 2. In the books, we will see that the answer is x squared minus 2xy plus y squared. Actually, we have the same idea with our first part. If you look at the first term here, the x squared, it comes from the first term of the binomial that is squared. So this is from x becomes x squared. If you look at the middle term, we simply multiply by 2 and then times the product of these 2 terms here. So x multiplied by negative y, you will get a negative sign. That's why you see here there is a negative sign. So negative 2xy in the middle term. And the y square actually comes when we square a negative y. Of course, we know that negative times negative will be positive. That's why here it is positive y squared. So these are the 3 terms when we square a binomial like this, the difference of 2 terms. So let us have a quick multiplication to verify our product here. So the x minus y all raised to 2, we can show that this is x minus y times x minus y. Then we will do the long method of multiplication. We distribute one term to the other terms. So you see here x times x will give us x squared. X times negative y is negative xy. Then the negative y times x can be written as negative xy also. Negative y times negative y is positive y squared. You see here the middle terms, they are like terms that we can add together. So we have x squared minus 2xy plus y squared. And that is the same product that we see on this formula on top. So we can now use this formula to solve some products of this pattern. Let's have example 1. 1 minus 2x raised to 5 all raised to 2. So we have the 3 terms here. The first term is the square of the number 1. In the middle, I put the constant 2, I copied the 1, I copied this 2x raised to 5. Actually, the negative sign is already in front. And the last term is the 2x raised to 5 power 2. There is no issue if you put also the negative sign here. Anyway, because of the square here, later it will just be deleted. Then we simplify each term. 1 square, we know it is 1. So the middle term minus 2 times 2 is 4, x raised to 5, and then plus 4x raised to 10. So this is our final answer. Let's have example 2. 4x minus 3y all raised to 2. So our three terms, the 4x is squared here in the first term, and then minus. I will put my constant 2. Then I will copy the 4x is here, the 3y is here. And then plus, for the third term, the 3y is squared on the last term. And then we will simplify all the three terms. For the 4x, all raised to 2 becomes 16x squared. The middle term, 2 times 4 is 8 times 3 is 24. And then the xy are included in the middle term. And the last term is 3y all raised to 2 becomes 9y squared. So this is our final answer. We're going to study special products of cube of binomial. We're going to have two parts. The first part is the sum of two terms, and it is raised to 3. In the books, you will find the special product to be these terms. We have 4 terms in the product here. So let us examine one by one. The first is x3. It comes from the first term here, x, and it is raised to 3. The second term, the constant 3 will always be there. So we're going to multiply the x and the y. But the first term x will be squared. So you see here 3x squared y. The third term, the constant 3 is always there. Again, we're going to multiply the x and y. But this time, we will square the second term, that is y. So you see here 3xy squared. And the last term here is the cube of this y. So it is y cubed. Now let us have a quick multiplication to confirm this product. So I copied the x plus y raised to 3. And we know by long multiplication, we can write x plus y times x plus y times x plus y. And then this x plus y times x plus y, we can simplify this using our special product of square of two terms. So we can have this x squared plus 2xy plus y squared. And then the x plus y is copied here. Now we are going to again do the long multiplication. One term here will be multiplied to the terms of the other group. Another term here will be multiplied to the terms of the other group. And the last one will also be multiplied to the terms of the other group. So you see here we have x squared times x will get the x cubed. the x squared times y will get this x squared y. Let's have this 2xy multiplied by x. We'll get this 2x squared y. This 2xy multiplied by y, we'll get this 2xy squared. And the last term for the trinomial y squared times x, we have the y squared x, or we can write like this, xy squared. And then the y squared multiplied by y, we'll have this y cubed. Next, we will collect like terms and combine them. You see here, the x squared y and the 2x squared y, they are like terms. Also, the 2xy squared and the xy squared are like terms. So we can combine them. 3x squared y, also these two like terms can be written as 3xy squared. So copying the x cube here, copying the y cube. So we have this x cube plus 3x squared y plus 3xy squared plus y cube. So this is our final answer. And we can see that this answer here is the same with our special product written on top. Now we are ready to use this formula to solve problems like this. So let's have example 1. This is 2a plus 5 all raised to 3. So in the answer, we expect 4 terms. So I put here 4 blanks. So the first blank is the first term 2a, we will raise into 3. Then the second term will be the times 3. And then I'm going to copy these 2 terms, 2a and 5, but the 2a must be squared. The third term, again the constant 3 will be there. I am copying these 2 terms, but this time the number 5 will be squared. And the last blank, the 5 will be raised to 3. And then we'll just simplify the terms. So this 2a raised to 3 will give us 8a cubed. Let us first simplify the 2a squared. We will get this 4a squared. Also the 5 squared in the third term will give us 25. We can simplify the 5 cubed. It will give us the 125. Then going to the next line, the a cube is copied here. Then we simplify, we multiply these terms, 3 times 4a squared times 5. We'll get this 60a squared. And then the third term, 3 times 2a times 25 equals 150a. And we just copy the 125. So this is our final answer. Let's go to example 2. X squared plus 2y all raised to 3. So I'm going to write the 4 blanks to represent the 4 terms. In the first blank is the first term, the x squared must be raised to 3. In the second blank, there must be the constant 3. Then I'm going to copy the 2 terms, but the first term must be squared. In the third blank, again I'm going to put the constant 3, and then I'm going to copy the 2 terms here, but the second term, the 2y, must be squared. And for the last blank, the 2y must be raised to 3. And then we're going to simplify each term. For this x squared all raised to 3 will give us the x raised to 6. Now in the second term, let us first simplify the x squared and then squared, it will give us the x to the fourth. So on the third term, the 2y raised to 2 will be simplified into 4y squared. The last term, 2y raised to 3, can be simplified into 8y cubed. Now going to the next line, we will simplify further the second and the third terms respectively. So we'll just copy the x raised to 6 down here. And for the second term, we're going to multiply 3 times x raised to 4 times 2y. It will give us the 6x raised to 4y. And then for the third term, we multiply 3 times x squared times 4y squared. It will give the 12x squared y squared. And the 8y cubed, we will simply copy here. So our final answer, x raised to 6 plus 6x raised to 4y plus 12x squared y squared plus 8y cubed. Let's go now to the second part. So this is x minus y all raised to 3. Or we can say this is difference of two terms and raised to 3. In the books, you will find these four terms to be the special product. So let us examine one by one. The first term is x cubed. It comes from the x here, that is raised to 3. And then minus the constant 3 is here, and then x squared. This is the x that is squared, followed by the y. And then plus another constant 3 will be there, and then the x, that is the first term, and then the y squared. This is the y to be squared in here. And then minus the y is raised to 3 also in the last term. So take note also that in the special product, we have alternating signs from positive to negative to positive and negative. So now we're going to have a quick multiplication to confirm the special product here. So I'm going to write the x minus y down here, raised to 3. So by our long multiplication in the power of exponent, I'm going to write x minus y times x minus y times x minus y. And then I'm going to simplify the first two factors. It will give me this x squared minus 2xy plus y squared. So we can apply our special product here for the difference of two terms. So these are the three terms for the special product. And then the x minus y is copied here. And then one by one, I'm going to take one term and multiply to the other terms of the other group. Same thing will happen to the negative 2xy, multiply to the terms of the other group, and also this term to be multiplied to the terms of the other group. So let's start with the x squared, multiply to the x, will give us this x cubed. Then x squared times negative y will give this negative x squared y. Next is this negative 2xy times x will have this negative 2x squared y. Negative 2xy times negative y will give this positive 2xy squared. Then the y squared multiplied by x will give xy squared. Then y squared times negative y will give this negative y cubed. Then let us collect like terms to be combined. You can see here, these two terms here are like. Also, these two terms are like that we can combine. So x cubed is copied. Then these two terms becomes negative 3x squared y. These two terms becomes 3xy squared. And then the negative y cubed is copied down here. So when we compare, the product here is the same with our special product written on top. There's also one idea here that this rule follows the x plus y raised to 3. Suppose we are discussing this rule. Let's have this example to be solved. So now I'm going to write the 4 blanks and then connected by the plus signs. So please follow me. The first blank, I'm going to put the x and then put the power 3. Next blank, I'll put the number 3 constant, and then the x will be squared followed by the negative y. And then plus for the third blank, for the third term, again the constant 3 will be there. I copy the x and also the negative y must be squared. On the last blank, the negative y or the second term of the binomial will be placed here and then raised to 3. Then let us simplify. The first term becomes x cubed. In the second term here, the negative sign of the y will be placed in front. So we can see it becomes negative 3x squared y. In the third term, the negative y is squared, so the negative sign will go away. It becomes positive. That's why in the third term, it becomes plus 3x y squared. In the negative y, all raised to 3, so the negative sign is raised to an odd number. It means the negative sign will stay. So this is negative y cubed. So you can see here again that the product here is the same with our special product written on top. So one conclusion can be made. If we're going to solve a difference of 2 terms and it is cubed, we can also use the idea of the first special product here. The idea for the x plus y raised to 3. So let us see one example. So the 10 minus 2m all raised to 3. Now I'm going to use the idea of the formula number 1. I'm going to write my 4 blanks and then connected by the plus signs. So the first blank is for the 10 raised to 3. The second blank, I'm going to write my constant 3, and then these 2 terms I'm going to copy here, but the first term, which is 10, must be squared. In the third blank, the constant 3 must be there. I will copy the 10 and the negative 2m, but this time the second term or the negative 2m must be squared. For the last blank, the negative 2m must be raised to 3. So let us now simplify the terms. The 10 cubed becomes 1000. For the 10 squared, I will simplify this first, becomes 100. The negative 2m in the third term is raised to 2. So I simplify this into 4m squared. Of course, the negative sign goes away, so it becomes positive. And the last term, the negative 2m raised to 3, becomes negative 8m cubed. And then let us simplify further. I copy the 1000 down here. For the second term, I multiply 3 times 100 times 2m. It gives 600m. Again, that is negative. And then the third term, I copy the plus sign. I multiply 3 times 10 times 4m squared. It gives 120m squared. And then the negative 8m cubed is copied here. So this is our final answer. Let's go to example number 2. 5p minus r squared all raised to 3. Again, I'm going to write my 4 blanks, representing my 4 terms. The first blank, I'm going to copy the 5p and then raise to 3. In the second blank, the constant 3 must be there, and I'm going to copy these two terms, but the first term 5p must be squared. In the third blank, the constant 3 is there, and then I copy the two terms again, but now the second term negative r squared is now squared. And the last blank, the negative r squared is raised to 3. Now let us simplify. The 5p raised to 3 equals 125 p cubed. Now in here the negative sign is placed in front. Then let us simplify this 5p squared. It becomes 25p squared. And then on the third term, we simplify this negative r squared and then squared. It becomes r raised to 4. The negative sign goes away. Now for the last term, negative r squared raised to 3, the negative sign remains because it is an odd number, and then the r is now raised to 6. So let us simplify further. The 125p cubed is copied down here. Then for the second term, the negative sign is there. I multiply 3 times 25p squared times r squared. It gives 75p squared r squared. For the third term, the positive sign is there. Then I multiply 3 times 5p times r raised to 4. It gives this 15p r raised to 4. And the negative r raised to 6 is copied down here. So this is our final answer. We're going to study special products of these forms. Two forms will be of this type, and the third special product will be of this form. Let's begin with our first type. In here, we're going to multiply binomial and trinomial of this form. In the book, you will find the special product for this to be a binomial, which is x cubed plus y cubed. So let us examine our factors here. Look at the binomial x plus y. If we look at our product, it is x cubed plus y cubed. It seems like we are simply putting the cube on each term of the binomial here, and we put in the final answer. And the same sign of positive is written in between them. It means to say we can examine our trinomial factor here. Here is x squared. This is the square of the first term of the binomial. The middle term is negative xy. This is the product of these two terms, x and y. But we should write the opposite sign. If we multiply x and y, it will give positive xy. But in here, the sign must be the opposite. Should be negative. So negative xy in the middle term. And the third term of the trinomial is y squared. And that is the square of this y here. So it is y squared. Binomial is x plus y, and the trinomial is x squared minus xy plus y squared. Your special product is simply the x cubed plus y cubed. Now let's have a quick multiplication to confirm the product of this binomial and trinomial using our long method. So I'm going to multiply the x with all the terms of the other group. Then later I will multiply the y with all the terms of this trinomial also. So it will appear like this. X times x squared, we will get the x cubed. Then x multiplied by negative xy, we will get this negative x squared y. Then x times the y square, we will get this xy square. Next is for the y term here of the binomial. I'm going to multiply first with the x square. The answer is x squared y. Next is the y multiplied by negative xy. We will get this negative xy square. And the y multiplied by y square, we will get this positive y cube. And from here, we're going to look for like terms. So this negative x squared y, there is a positive x squared y here. Also, this xy square, positive, there is another term which is same literal coefficient xy square, and this is negative. So it means to say we can cancel these terms respectively, and then we will collect the terms that will remain. Obviously, this is x cubed that will come, and also the plus y cubed. So this is our final answer. As you can see, this answer is the same with our special product that is written up here. Now we are ready to use this formula when we encounter multiplication of polynomials of this pattern. Let's have example 1. b plus 3 multiplied by b squared minus 3b plus 9. First, let us analyze each term if pattern is met. So there is no question with the binomial. We will simply check the trinomial part. Okay, so the first term here of the trinomial is b squared. It is simply the square of this b. So the first criterion is checked. The middle term, if I multiply b by 3, I will get positive 3b, but I should write the opposite sign, negative 3b. So the second criterion is checked also. What about the third? The third term is 9. So this 9 is simply the square of the number 3. So the third criterion is checked. So it means to say the pattern is met. In that case, what we will do is we're going to write here two blanks to represent our special product. In the first blank, I will copy the b, I will put in the first blank, and then put the power 3. And then I'll make sure that this is plus. And for the second blank, the 3 will be put on the blank, and then we'll put the power 3 or cube. And then we will simplify. So the b raised to 3 will be b cubed, and then the 3 cubed will be 27. So this is our final answer. Let's have example 2. 2x plus 5y is the binomial, multiplied by the trinomial 4x squared minus 10xy plus 25y squared. We can rewrite the problem into same pattern of the special product. So for the 4x squared, we can rewrite this as 2x raised to 2. For the negative 10xy, we can factor this out in such a way that we can see the terms of the binomial. So the 2x and the 5y are there, and the sign must bear the opposite. So 2x and the 5y, and then the minus sign is here. And for the third term, the 25y squared, we can write as 5y all raised to 2. So we can say that the pattern is met. So what we'll do now, we'll go to that same problem and then we'll put the equal sign. We will now put the two blanks to represent the two terms of the special product. Let's begin with the first blank. I will collect the 2x and I will put the power 3 and then plus. For the second blank, the 5y is copied here and then power 3. We will simplify further. The 2x raised to 3 is equal to 8x cubed and the 5y raised to 3 is 125y cubed. So this is our final answer. Let's go now to the second type of special product. We have this binomial x minus y multiplied by the trinomial x squared plus xy plus y squared. In the books you will find that the special product for this is a binomial which is equal to x cubed minus y cubed. If we look at our binomial here, it seems like we simply take the cube of this x and write here, and for the sign, if this is minus, same negative sign is coming here. And then the y is copied and then with power 3. So we're going to analyze the trinomial. So this is x squared. This is simply the square of this x. The middle term is xy. So it seems you're multiplying the x and negative y. But we should write the opposite sign. Because if I multiply x by negative y, I will get negative xy. But based on the pattern, I should write the opposite sign. So this is plus xy. And the third term of the trinomial is simply the square of this negative y. So negative y is squared, it will give positive y squared. So if a certain multiplication of binomial and trinomial falls on this category, we can simply write the final answer as a simple one. This is x cubed minus y cubed. Formula B or special products A and B have similar pattern. Now we are ready to see example 1. So this is AB squared minus 2 is our binomial. In the trinomial, it's written a squared b raised to 4 plus 2ab squared plus 4. And then we can rewrite the problem into same pattern of the special product. For the binomial, we simply copy. Now, for the first term of the trinomial, let us show that this is the square of the first term, ab squared. So this is ab squared, and then the power 2 is outside. If we simplify this, we will go back to our a squared b raised to 4. The next, the middle term, let us show that this middle term is the product of this binomial. So ab squared is here, and the negative 2 is here. But when we get the product of this, we should write the opposite sign. Okay, if we multiply these two, we will get a negative sign, but in the pattern, we should write the opposite sign, so this is plus. For the third term, we should show that this is the square of this second term of the binomial. So this is negative 2. If we square this, it will go back to our positive 4. So it means the pattern is met. In that case, we will go back to our problem. Then we will put now the special product. Let us write the two blanks to represent our two terms of our product. So the first blank here, we're going to copy the ab squared. We'll write here and then put the power 3. And then we should write the negative. And then for the second blank, the 2 is copied and then write the power 3. Then we will simplify now. So this term here becomes a cubed b raised to 6, and then minus the 2 cubed is 8. So our final answer is a cubed b raised to 6 minus 8. Let's have example 2. This is 5xy minus 1 multiplied by the quantity 25x squared y squared plus 5xy plus 1. So again, we will check the pattern. We will rewrite this problem and see if this pattern falls on our special factors pattern like this. So there is no issue with our binomial. We simply copy that. Now for the trinomial, we will check one by one. The first term, it must satisfy that this is the square of the first term, the 5xy. So this 5xy, if we square this, we will get back to that 25x squared y squared. So the first criterion is met. And then for the middle term, let us show that this is the product of the two terms of this binomial. So the negative 1 is here, the 5xy is here. If we multiply this, we will get a negative sign, but as a rule, we should write it as positive. So the second criterion is checked. Let's see the third. The third criterion, we should show that this 1 here is the square of the negative 1. So if this negative 1 is squared, it will go to positive. So again, the third criterion is checked. It means to say the pattern is met. In that case, we will go back to our problem. Then we will write the two blanks to represent the terms of the special product. For the first blank, I will collect the 5xy, then I will put power 3. Then followed by the negative sign, and then for the second blank, the 1 will be raised to 3. Then we'll just simplify. The 5xy raised to 3 becomes 125 x cubed y cubed, and then minus 1 cubed is 1. So this is our final answer. Let's go now to our third type, and this is square of trinomial. As you can see here, we have three terms, x plus y plus z, all raised to 2. In the book, you will find that the answer for this is 6 terms. So let us examine one by one. We can group the 6 terms into 2 groups. The first 3 is one group. The last 3 is another group. So let us examine the first 3 terms. So these 3 terms are actually the square of each of the terms of the binomial. So you see, the x is squared here, the y is squared here, and the z is squared here. For these last 3 terms, the pattern is we're going to multiply 2 terms at a time and then multiplied by 2. So you see here, the xy is multiplied together and then times 2. The x and z are multiplied together and then times 2. The y and the z are multiplied together and then times 2. And that's it. This is now our special product for the square of trinomial. Let's have a quick multiplication to confirm if this special product is actually the same answer if we're going to have a long method of multiplication for this square of trinomial. So what we'll do, we're going to expand, so we can show that this is x plus y plus z times x plus y plus z. Then we will do a long multiplication. So this variable x, I'm going to multiply to all the terms of the other group. So it will come like this. X times x will get x squared, x times y is xy, x times z is xz. Next, the y, I'm going to multiply with the x, I'll get xy. Then y times y is y square, y times z is yz. And then plus, now the z multiplied to the x, it is xz. Z multiplied to the y, it is yz. And then z multiplied to z will give z squared. And then I'm going to remove the grouping symbol and then to combine like terms, if any. But in writing my final answer, at first, I'm going to collect all terms with squares. So this is x squared, there is y squared, there is z squared. I'll write them first in here, and then I will collect the like terms. There is an xy here, positive, there is positive xy here, so combining them, I will get the 2xy. The xz in blue color, there is another xz here in blue color. They are like terms, so we can combine them to be 2xz. Now, the other one is the yz, positive. Another positive yz is here. We can combine them together. We'll get the 2yz. So, this is our final answer with 6 terms. So, these 6 terms, the final answer here is same with our special product written on top. So, it means to say, we can now use this special product to solve problems that will fall on this pattern. So let's have example 1. A plus 2b minus 5 all raised to 2. So as per our special product, we're going to square each term of this trinomial. So you see here, the a is squared. The 2b is also squared here. The negative 5 is also squared. So this comprises our first group. And for our second group, we're going to multiply 2 terms at a time and then multiplied by 2. So at first I'm going to multiply a and the 2b and then times 2. So you see here 2 times a times 2b. Next I'm going to multiply a and the negative 5 and then times 2. For the last term, I'm going to multiply 2b and the negative 5, it's here, and then times 2. Next, I'm going to simplify now the 6 terms. So this term here becomes a square. The 2b squared is 4b squared. The negative 5 is squared, it becomes positive 25. For the fourth term, this 2 times a times 2b will give 4ab. For the fifth term, we multiply 2 times a times negative 5, we'll get negative 10a. For the last term, we multiply 2 times 2b times negative 5. So this is negative 20b. So for our final answer, this is a squared plus 4b squared plus 25 plus 4ab minus 10a minus 20b. Let's see example 2. 3x minus y squared plus 10 all raised to 2. So let us use our special product. Let us square each term here. So 3x is squared. The negative y squared is also squared. And the positive 10 is squared. And for the second group, I will collect 2 terms at a time and then multiplied by 2. So first I'm going to multiply 3x and negative y squared. It's here, and then times 2. And then plus, I'll multiply 3x and the 10. It's here now, 3x times 10 and then times 2. And the last term, I'll multiply the negative y squared and the 10. It's written here, and then times 2. Then we will simplify each term. The 3x raised to 2 becomes 9x squared. This negative y squared and then square outside, the negative will go away. It becomes y raised to 4. The 10 squared is now 100. So the first group is now complete. I'll go to the second group. For the fourth term here, I'm going to multiply 2 times 3x times negative y squared. So the negative sign comes here, and then 6, and then x, then y squared. For the fifth term, I'll multiply 2 times 3x times 10. It will give 60x. And the last term, I will multiply 2 times negative y squared times 10. So the answer is negative 20y squared. So we have now the 6 terms as our final answer. So this is 9x squared plus y raised to 4 plus 100 minus 6xy squared plus 60x minus 20y squared. One more point that I want to make. Since we are putting square to each term of this trinomial, it means to say the first 3 terms in the final answer must always be positive. Thank you for watching the video. See you again next time. Hi everyone. Today we're going to study degrees and zeros of polynomial. Let's begin with degree of the polynomial. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. Examples, we have here 4 polynomials. The first is 4x plus 2. This is a polynomial in x. The highest power is 1. Remember that the degree of the constant 2 is 0. So in here, the degree is 1. Second polynomial, 2y squared minus 3y plus 4. This is a polynomial in y. And the highest power is 2 among the terms. So the degree is 2. Third polynomial is 5x cubed minus 4x squared plus x minus 2. The highest power is 3. So the degree is 3. Fourth polynomial, 7u raised to 6 minus 3 halves times u raised to 4 plus 4u squared plus u minus 8. This is a polynomial in the variable u. The highest power is 6, so the degree is 6. For the polynomial, when degree is 1, there is a special name for this, and we call this linear polynomial. When degree is 2, we call this quadratic polynomial. When degree is 3, we call this cubic polynomial. Let's go now to zero of a polynomial. If p of x is a polynomial in x, and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equals k, and is denoted by p of k. A real number k is said to be a zero of a polynomial p of x if p of k equals 0. Example 1. Find the corresponding value of p of x equals x squared minus 3x minus 4 at x equals -1, x equals 2, and x equals 4. Let's begin with the value of the function at x equals -1. In symbol, we write p of -1. The function p of x is given here. So what we're going to do is we substitute all x by -1. So the x squared becomes the square of -1 minus the 3x becomes 3 times -1, then -4. Simplifying the square of -1, we have +1. -3 times -1 is +3. Then the -4. Simplifying this, we have now 0. This is the value of p of -1. Then we go to the next at x equals 2. In symbol, we write p of 2. Evaluating the p of 2, we're going to substitute all x by 2. The x squared now becomes 2 squared minus 3x becomes 3 times 2, then minus 4. We simplify 2 squared as 4 minus 3 times 2 is 6, then we attach the -4. Simplifying 4 minus 6 minus 4, we have now -6. Then we go to at x equals 4. In symbol, we write p of 4. We're going to substitute all x by 4. So the x squared becomes 4 squared minus 3x becomes 3 times 4, then the -4. 4 squared is 16 minus 3 times 4 is 12 minus 4. When we simplify, the answer is 0. These are the corresponding values of p of x when x equals -1, at x equals 2, and x equals 4 respectively. Since p of -1 equals p of 4 and both are equal to 0, then -1 and 4 are zeros of the polynomial. Example 2. Find the zero of the polynomial p of x equals 2x plus 3. Step 1. Let k be the zero of the polynomial. Then we evaluate p of k, which means the p of x here becomes p of k, and this is now the value, 2k plus 3. Step 2. We set p of k equals 0, and we solve for k. Our equation is p of k equals 2k plus 3. Now this becomes 0. We can disregard the p of k, then we will solve here for k. This +3 we transpose to the right. We have now 2k equals -3. Then isolating k, we divide the left side and the right side by the coefficient of k, which is 2. By doing that, the value of k equals -3/2. This is the final answer. Example 3. Find the zeros of the polynomial p of x equals x squared minus 3x minus 4. Step 1. Let k be the zero of the polynomial. Then we evaluate p of k. The p of x becomes k squared minus 3k minus 4. Then step 2. We set p of k equals 0. Then we solve for k. We copy our equation in here. Then this is equal to 0. We can disregard the p of k symbol. And from here, we're going to solve for k. We can solve this by factoring. And this becomes k minus 4 times the quantity k plus 1, then equals 0. We equate each factor to 0, which means the k minus 4 equals 0 and the k plus 1 equals 0. Then we solve for k for each of these equations. In the first equation, we transpose the negative 4 to the right. So the value of k equals 4. In the second equation, we transpose the positive 1 to the right. So k equals negative 1. These are the values and we call them zeros of the polynomial. Hi everyone, today we're going to study polynomial remainder theorem. First, let us see this example. Evaluate the polynomial 5x minus 4x squared plus 3 at these 3 points. By notation, we write the p of x equals the given polynomial. Then we start with the first point at x equals 0. We use the notation p of 0 to denote the first problem. P of 0 means we're going to replace all x by the value 0. So it becomes 5 times 0 minus 4 times 0 squared plus 3. This 5 times 0 and this negative 4 times 0 squared will cancel out, meaning it becomes 0. So the answer is positive 3. Therefore, the p of 0 equals 3. Next point, x equals negative 1. By notation, we write here p of negative 1. We evaluate the polynomial, that is, to replace all x by the value negative 1. So 5x becomes 5 times negative 1 minus 4x squared is now 4 times the square of negative 1, then plus 3. 5 times negative 1 is negative 5. This square of negative 1 becomes positive 1 plus 3. That is equal to negative 6. Therefore, p of negative 1 equals negative 6. Then, x equals 2. We write the notation p of 2. Evaluating the polynomial, we have to replace all x by the value 2. So it becomes 5 times 2 minus 4 times 2 squared plus 3. 5 times 2 is 10 minus this 2 squared is 4. Then plus 3. We simplify this. 4 times 4 becomes 16. So we have now 10 minus 16 plus 3. That will be negative 3. So p of 2 equals negative 3. These are the answers. We go now to polynomial remainder theorem. Polynomial remainder theorem states that if a polynomial p of x is divided by the binomial x minus a, the remainder is p of a. Example 1. Find the remainder when x cubed plus 3x squared plus 3x plus 1 is divided by x plus 1. We see that the given divisor is x plus 1. In the theorem, we need to show the negative sign. So this x plus 1 is equal to x minus negative 1. So the value of a, or the constant, is negative 1. That means, by remainder theorem, the remainder must be p of negative 1. Let us now evaluate p of negative 1 with this polynomial. So p of negative 1 equals negative 1, that is cubed, plus 3 times the square of negative 1, plus 3 times negative 1, then plus 1. Simplifying now, the cube of negative 1 is negative 1, plus 3 times the square of negative 1 is positive 1. Then 3 times negative 1 is negative 3. Then plus 1. We now simplify and this becomes 0. Example 2. Find the remainder when x cubed minus ax squared plus 6x minus a is divided by x minus a. The given divisor is x minus a. We have here the negative sign, so we're going to use the value a itself in the theorem. By remainder theorem, the remainder now is p of a. Let us now evaluate this polynomial with respect to a. So that will be a cubed minus a times a squared plus 6a minus a. The cube of a is a cubed. A squared times a is a cubed. So this is minus a cubed plus 6a minus a. When we simplify, a cubed minus a cubed is 0. Then 6a minus a is 5a. This is our answer. Hi everyone, today we're going to study factor theorem. Factor theorem is a special kind of the polynomial remainder theorem. It states that the binomial x minus a is a factor of the polynomial p of x if p of a equals 0. In general, a polynomial f of x is a factor of another polynomial p of x, such that when p of x is divided by f of x, the remainder is 0. Example 1. Prove whether x plus 1 is a factor of x cubed plus x squared plus x plus 1. Our p of x is x cubed plus x squared plus x plus 1. Then, if x plus 1 is a factor of this p of x, then by the factor theorem, p of negative 1 must be 0. Now, let us evaluate p of negative 1. So, this is now cube of negative 1 plus the square of negative 1 plus negative 1 plus 1. Cube of negative 1 is negative 1 plus the square of negative 1 is positive 1. Then we write here minus 1 plus 1. When we simplify, this becomes 0. Since p of negative 1 equals 0, then x plus 1, the binomial, is a factor of the p of x, that is x cubed plus x squared plus x plus 1. Example 2. Determine whether x plus 2 is a factor of x cubed plus 3x squared plus 3x plus 1. Our p of x is x cubed plus 3x squared plus 3x plus 1. Then we say that if x plus 2 is a factor of p of x, then by the factor theorem, p of negative 2 must be 0. Let us now evaluate and check if p of negative 2 equals 0. So we have now the cube of negative 2 plus 3 times the square of negative 2 plus 3 times negative 2 plus 1. When we simplify, the cube of negative 2 is negative 8 plus 3, then multiplied by the square of negative 2, that becomes positive 4. Then 3 times negative 2 is negative 6 plus 1. 3 times 4 is 12. Then when we combine the numbers, we have negative 1. So p of negative 2 equals negative 1. Since p of negative 2 is not equal to 0, then x plus 2 is not a factor of x cubed plus 3x squared plus 3x plus 1. Hi everyone, today we're going to study factoring. Specifically, this is factor the greatest common factor, GCF, from a polynomial. First, let us define greatest common factor. The greatest common factor, or GCF, of two or more expressions is the largest expression that is a factor of all the expressions. How to find the greatest common factor? We're going to follow some steps. Step 1. Factor each coefficient into primes. Write all variables with exponents in expanded form. Step 2. List all factors matching common factors in a column. In each column, encircle the common factors. Step 3. Bring down the common factors that all expressions share. Step 4. Multiply the factors. Let's have an example. Find the GCF, or greatest common factor, of the three terms. 21x cubed, the second is 9x squared, the third term is 15x. In step 1, let us factor each coefficient into primes. We write all variables with exponents in expanded form. So the 21x cubed is now factored out into 3 times 7. That is the prime factors of 21. And for the x cubed, we are going to write the x here 3 times. For the 9x squared, this is equal to 3 times 3 times x times x. For the 15x, this is equal to 3 times 5 times x. Step 2. List all factors matching common factors in a column. So the factors are now written like this. For the common factor 3, it is written in one column. There is also another common factor of x. written in another column. It says in each column, encircle the common factors. So we encircle the 3, the common factor 3, and also the common factor x. Step 3, bring down the common factors that all expressions share. So the 3 is brought down here, also the x, and then the step 4, we will multiply the factors. So the greatest common factor equals 3x. Let us go to factoring. What is factoring, by the way? Splitting a product into factors is called factoring. Example, find the factors of 6. It is showing here that the factors of 6 are 2 and 3. We know that there are other factors like 6 times 1 for this number 6. However, for this topic of factoring, we will only consider prime factors. Let us note that prime numbers are integers greater than 1 whose only factors are 1 and itself. Examples are 2, 3, 5, 7, 11, 13, and so on. Let us discuss now factoring the greatest common factor from a polynomial. We are going to follow some steps. The step 1 says, find the GCF, or the greatest common factor of all the terms of the polynomial. Step 2, rewrite each term as a product using the GCF. Step 3, use the reverse distributive property to factor the expression. Step 4, check by multiplying the factors. Let's have example 1. Factor the trinomial 6x cubed minus 9x squared plus 12x. Our step 1 says, find the GCF of all the terms of the polynomial. In here, the GCF is 3x. Looking at the numbers 6, 9, and 12, the greatest common factor of these 3 numbers is 3. For the variables x cubed, x squared, and the x, the greatest common factor is x. So the GCF of this trinomial is 3x. Step 2, let us rewrite each term as a product using the GCF. It means we're going to split each term. Look at the first term. The 6x cubed is split into 2 factors in such a way that one factor should be the GCF. So the 6x cubed is now factored out into 3x and 2x squared. The second term, negative 9x squared, is now factored out into negative 3x, the GCF, times the 3x. For the 12x, the factors are the GCF 3x and the number 4. For step 3, use the reverse distributive property to factor the expression. It means to say we're going to remove first the GCF from the 3 terms. So see, the GCF is now outside, and then on the second factor, we're going to collect all terms that will remain for each term here after removing the GCF. Look at the first term here. After removing the GCF, the 2x squared remains, so it is written here 2x squared. For the second term, after removing the GCF, only the 3x is coming, so this is minus 3x. And then plus, for the third term, after removing the GCF, only the number 4 remains, so we will copy here 4. Step 4, let us check our answer by multiplying the factors. We should go back to the original problem after the multiplication. So the 3x multiplied by the 2x squared, I will get that 6x cubed. And then the 3x multiplied to negative 3x, the answer is negative 9x squared. And then 3x times 4 is positive 12x. So we are sure that this is correct, and this is our final answer. Let's have the second example. In here, there are two big groups. It is a difference of binomial. Look at this first group here. It is a product of 3y times the quantity y plus 7, and then minus the second group is 4 times the quantity y plus 7. Let us go to our step 1. Find the GCF of all the terms of the polynomial. So our GCF is this y plus 7. That is the common in the first group and in the second group. So I wrote here the GCF, that same y plus 7. Step 2, rewrite each term as a product using the GCF. In this problem, it is already in the form of a product in such a way that one of the factor is the GCF. So we just copy that same problem. In step 3, use the reverse distributive property to factor the expression. So we're going to remove first the GCF. So removing the GCF here, we expect two terms in the second factor. In the first blank here, I'm going to write the remaining term after removing the GCF. So looking at this first group, I can see here that 3y will remain after I remove the GCF. So I will write the 3y. And then plus. For the second blank, I'm going to write here the remaining term after removing the GCF. So that is the negative 4. So negative 4 will come down here. So this is plus and minus. I will simplify this into negative 4. And step 4, let us check by multiplying the factors. So we want to multiply these factors and hoping that we will get back the original problem. So the first group is this 3y times the GCF. So this is our 3y. If I multiply by the first group or the GCF, I will get the first group here. And then this negative 4 multiplied by the GCF here, I will get the second group, the negative 4 times the quantity y plus 7. So now I am sure that this answer or these factors are correct, and this is our final answer. today we're going to do factoring, and we will factor difference of two squares, and this is the form x squared minus y squared. Let us make a review for special product. When we multiply x plus y times x minus y, the answer is a binomial x squared minus y squared. The factors are called conjugates. It means the conjugate of x plus y is the x minus y, and vice versa. While the product, we call this difference of two squares. For today's lesson, we are going to do the reverse process. The problem will come to you as this product, and then you are required to give the factors of this form. How to factor difference of two squares? In step 1, rewrite the two terms as squares of some terms. Step 2, write the factors following the pattern. The x squared minus y squared equals the binomial x plus y times x minus y. Let us have example 1. Factor the binomial x squared minus 9. For step 1, we will rewrite the two terms as squares of some terms. So the x squared is now written as the square of x, and then minus the 9 is now 3 squared. For step 2, we're going to follow this pattern. It means we expect two binomials in our answer. But take note that the signs must be different. One is positive, the other is negative. We're going to put x on the first blank of the binomials. And then the 3 will be the second term of each of the binomial. So we see here we have the x plus 3 times the x minus 3. So this is our answer. Let us have example 2. Factor 64y squared minus 1. Again, we are going to rewrite these two terms into squares of some terms. The 64y squared can be written as the square of 8y, and then minus the 1, we can write it also as the square of 1. And then for our answer, there will be two binomials. In the first term, it will be 8y. Also 8y in the first term of the second binomial. And for the signs, it must be opposite. One is minus, the other is plus. In our answer here, the negative comes first, followed by positive. And it doesn't matter as long as the signs are different. Now for the second term, we copy that 1. So it's now placed here and also in here. So our answer is the binomial 8y minus 1 times 8y plus 1. This is our final answer. Let us consider example 3. Factor the binomial 48x raised to 4 y squared minus 75 y squared. the terms are not perfect squares. We can see here that the variables are perfect squares. However, the coefficients are not. Therefore, these two terms are not perfect squares. But remember, we can check for greatest common factor of each term. I found out that the GCF is 3y squared. So if I pull out that greatest common factor, this first term here will become 16x raised to 4, while the 75y squared will be 25. Of course, the negative sign we will just copy here. So for our problem here now, we have monomial times binomial. And then we will check if this binomial here have terms which are perfect squares. The 16x raised to 4, we can write this as the square of 4x squared, and then minus. We know that 25 is a perfect square number, so that is 5 squared. And then we will just copy that 3y squared down here. And then we will have the step 2. For step 2, we are now expecting two binomials here. The first term will be the 4x squared. It's now here and also here. And then for the signs, we will have the plus and minus. And for the second term of the binomials respectively, it will be this number 5. It's now here and also here. So our final answer is this 3y squared times the binomial 4x squared plus 5 times the binomial 4x squared minus 5. And this is our final answer. Hi everyone. Today we're going to study factoring, and we are going to factor perfect square trinomials of this form: x squared plus or minus 2xy plus y squared. First, let us review our special product, the square of the binomial x plus y. And the answer is a trinomial x squared plus 2xy plus y squared. Also, if we have the square of x minus y, the answer is a trinomial x squared minus 2xy plus y squared. This trinomial and this trinomial are called perfect square trinomials because both of them comes from the square of binomials. For today's lesson, we are going to have the reverse process. The problem will come to you as this product, and you will be required to provide factors which is the square of binomial, either of this form or this form. How to factor perfect square trinomials? We are going to follow these 3 steps. Step 1, check if the trinomial fit the pattern of the perfect square trinomials, either this form x squared plus 2xy plus y squared, or this form x squared minus 2xy plus y squared. In step 2, write the square of the binomial. And step 3, check by multiplying the factors. Let us have example 1. Factor the trinomial 25x squared plus 20x plus 4. Let us check if this trinomial is a perfect square trinomial. First, our 25x squared and the number 4, we can rewrite it as the square of some terms. So the 25x squared is now the square of 5x, and the number 4 is 2 squared. For the middle term 20x, what we will do, first, let us write the 5x in here and the number 2, and these are the bases of the first and the third terms respectively. And then we will multiply by 2. And this number 2 is always constant. When we multiply these 3 factors here, we are hoping that the answer will be the middle term. So 2 times 5x times 2 will give us that positive 20x. So it means to say, this given trinomial is a perfect square trinomial. We can now proceed to our step 2, write the square of the binomial, and that will be our answer. So to write our answer, we're going to put 5x as the first term here, and that 5x is the base of the first term, and then plus this positive sign comes from the sign of the middle term, and the number 2, and this number 2 is the base of the third term. And then we will not forget the square outside. So this is our answer, the square of 5x plus 2. Now for the step 3, we're going to check our answer if it is correct. We're going to expand and hope that we will get back our original problem up here. So when we expand a binomial, it will follow this pattern here. So the 5x squared, it will give me the 25x squared, and that is the first term of the trinomial. If I square 2, that is equal to 4, and that is the third term of the trinomial. Now I will multiply 5x times 2 and times 2, and that is equal to 20x. So the square of 5x plus 2 is our final answer. Let us go to example 2. Factor the trinomial 16x squared minus 8xy plus y squared. I wrote my steps here. So first, I'm going to rewrite the 16x squared into the square of 4x and the y squared to be the square of y. For the middle term, first I will write the minus sign, and then the 4x and the y are written in the middle, and then times 2, and that is a constant. And I will hope that if I multiply 2 by 4x and by y, it will give me that 8xy. And it is. So it means to say, this trinomial is a perfect square trinomial. So the pattern is satisfied. I can now go to step 2. I will now write my answer. And my answer, or my factors, is the square of the binomial. So I will collect the 4x. I will put it here as the first term of the binomial, and then minus. The sign comes from the sign of the middle term, and the second term here is the y, which is the base of the third term. Of course, I will not forget the square outside. So this is my answer, the square of 4x minus y. Going to step 3, I will check my answer if it is correct by multiplying the factors. Or I can say that I will expand my binomial. If I do that, it will come to this pattern. So if I square 4x, it will give me 16x squared, and that will be the first term of the trinomial up here. If I square negative y, it is equal to y squared positive, and that is the third term of the trinomial. Now, I will multiply 4x by negative y and times 2. That is equal to negative 8xy. So, my answer, square of 4x minus y, is correct. And that is my final answer. Let's have example 3. Factor the trinomial 100x squared y minus 80xy plus 16y. I can see here that the first term and the last term are not perfect squares. So I can say that this is not a perfect square trinomial. However, I can see that there is a greatest common factor among the three terms, and that GCF is 4y. So I will factor out the GCF, and for the first term, when I remove the GCF, what remains is the 25x squared. For the second term, what remains is the negative 20x. For the third term, what remains is 4. So it means to say, I have now a new problem here. 4y times a trinomial 25x squared minus 20x plus 4. Now, I will check if this new trinomial is a perfect square trinomial. I will rewrite 25x squared into the square of 5x, and that 4 to be the 2 squared. In the middle term, first I will copy the sign, the negative. Then I will take this 5x right here. I will take this 2, put it here, and then times 2. If I multiply the 2 times 5x times 2, this will be equal to the negative 20x. So it means to say, this is a perfect square trinomial. Of course, I will not forget my 4y to be copied down here. So I will now go to step 2 to write my answer, to write the square of the binomial. First, I will copy the 4y, and then for the binomial, it will be the 5x as the first term, then minus, the sign comes from the sign of the middle term, and then the second term is the number 2, which is the base of the third term. Again, I will not forget the power 2. So this is my answer. 4y times the binomial, or the square of the binomial, 5x minus 2. Now, for step 3, I will check if my answer is correct. First, I'm going to expand the 5x minus 2 all squared. So the 5x squared is equal to the 25x squared. It is written here. If I square negative 2, it will be positive 4. I'm going to multiply 5x times negative 2 times 2. It will give me the negative 20x. And the 4y here, I can write it there and then start to multiply the 4y to each term of the trinomial. And it will give me this original trinomial 100x squared y minus 80xy plus 16y. So I was able to confirm that my answer here is correct. And this is my final answer. Hi everyone. Today we're going to factor trinomial of this form, x squared plus bx plus c. First, let us review multiplying two binomials. In here I have x plus m times x plus n. So we know how to multiply this. I'm going to get the x from the first group and multiply to all the terms of the other binomial. So x times x is x squared, x times n is positive nx. The next is the m to be multiplied to the other members of the other group. So m times x is mx, m times n is mn. And then I can see that the two terms in the middle has a common factor of x. So I put the common factor x outside. So the other factor will be n plus m. Or since our last term here is mn, I want to interchange the n and the m, and there will be no issue on that. So here it is now m plus n multiplied by the quantity x. So when we multiply this x plus m and the x plus n, this is our answer. So for today's topic, that we're going to factor trinomial in the form x squared plus bx plus c, and to compare with our review multiplication on top, I can say that the b here is equal to that m plus n, and the c, or the constant, is equal to that product m times n. And then later, what we want to get are factors of this form, x plus m times x plus n. Now, we will learn how to factor a trinomial of the form x squared plus bx plus c. We're going to follow some steps. Step 1. Write the factors as two binomials with first terms x, just like this. Step 2. We're going to find two numbers m and n. And this m and n will be those terms that we're going to write on the blanks in the step 1. But there are two conditions for this m and n. This is the first condition. If we multiply the m and the n, it should be equal to the c. And this c is the constant of our trinomial. The next condition is if we add the m and n, so that is m plus n, it must be equal to b. And this b here is the coefficient of the x in the middle term of the trinomial. So once we comply the step 2, we will go now to step 3. We will use m and n as the last terms of the factors. So it will be like this now. X plus m multiplied by x plus n. And step 4, we're going to check our answers. We will check by multiplying the factors, and it must come back to its original problem or the original trinomial. Let us have some examples. Example 1. Factor the trinomial x squared plus 13x plus 30. Step 1 says, let us write the factors as two binomials with first terms x. So I wrote like this: the x plus blank and then x plus blank. In step 2, let us find two numbers m and n such that the product of these two numbers is equal to c and the sum of these two numbers is equal to b. Here is the list of factors of 30. The first is 1 and 30. The second is 2 and 15. Third, 3 and 10. Fourth, 5 and 6. Now on this column, we are going to add the factors. 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 equals 11. As we can see here, this 13 here matches our b. It means to say the factors 3 and 10 is what we want for the m and n. So step 3, we are going to use the m and n as the last terms of the factors. So from here, the 3 and 10, we're going to put on the blanks. So it's now x plus 3 times x plus 10. Step 4 says, just to check our answer, we're going to multiply these two binomials. So x times x will give me x squared. X times 10 will be 10x. 3 times x is 3x. 3 times 10 is 30. In the middle terms, the 10x and the 3x, we can combine them. And the final answer is x squared plus 13x plus 30. And we can see that the product here is the same with our original trinomial on top. So what does it mean? It only means our answer here is correct. And this is our final answer. Let us have example 2. Factor x squared minus 11x plus 24. Step 1, let us write the factors as two binomials with first terms x. So x plus blank multiplied by x plus a blank. Step 2, let us now find the two numbers m and n. We are looking for the factors of 24, and here are the factors. 1 and 24, negative 1 and negative 24, 2 and 12, negative 2 and negative 12, 3 and 8, negative 3 and negative 8, 4 and 6, negative 4 and negative 6. And then on this column, we are going to add the factors. 1 plus 24 is 25. Negative 1 plus negative 24 is negative 25. 2 plus 12 is 14. Negative 2 plus negative 12 is negative 14. 3 plus 8 is 11. Negative 3 plus negative 8 is negative 11. 4 plus 6 is 10. Negative 4 plus negative 6 is negative 10. We can see now that this negative 11 as the sum matches our value of b. So it means to say we're going to use the m and n as the last terms of the factors. That is the step 3. This negative 3 and negative 8 are our m and n respectively. So we're going to put these two values on the blanks. So this is now our binomials. X minus 3 times x minus 8. In step 4, if our answer is correct, by multiplying these two binomials. So we have now x times x is x squared. X times negative 8 is negative 8x. Then negative 3 times x is negative 3x. Then negative 3 times negative 8 is positive 24. And then the middle terms, we can see that they are like terms that we can combine. So we have now the final answer, x squared minus 11x plus 24. And our answer here is the same with our original trinomial on top. It means the x minus 3 times x minus 8, and that is our final answer. Let us have example 3. Factor the trinomial x squared minus 2x minus 35. Step 1. Write the factors as two binomials with first terms x. So here it is, x plus blank times x plus blank. And then let us find two numbers, m and n. So we're going to find the factors of this negative 35. So the factors of negative 35 are on this column. First pair is 1 times negative 35. Second is negative 1 times 35. Third, 5 times negative 7. Fourth, negative 5 times 7. On this column, we're going to add the factors. 1 plus negative 35 is negative 34. Negative 1 plus 35 is 34. 5 plus negative 7 is negative 2. Negative 5 plus 7 equals 2. But we're looking for a sum that is equal to the b, and here it is, the negative 2. It means to say, we're going to the step 3 to use the m and n, these two terms here, this pair of factors, to be placed on the blanks. So here it is now, we have the x plus 5 times x minus 7. So step 4, we will check our answer if correct by multiplying these two factors. And we will hope that the answer will be same with our trinomial here. So multiplying the x and the x, that is x squared, x times negative 7 is negative 7x. Then 5 times x is positive 5x. 5 times negative 7 is negative 35. So we're going to combine the two terms in the middle, the negative 7x and the 5x, we will have a negative 2x. So our final answer here is x squared minus 2x minus 35. And we can see that the answer here is the same with our original trinomial on top. It means to say the binomials x plus 5 times x minus 7 are correct and considered to be our final answer. Let us have example 4. Let us factor x squared minus 6x plus 10. Step 1, I'm going to put here the x plus blank and then times x plus blank. Step 2, let us find two numbers m and n, the factors of 10, such that later on we will add them to get a value of b. So on this column, the factors of 10 are 1 and 10, negative 1 and negative 10, 2 and 5, negative 2 and negative 5. In this column, we're going to add each pair of factors. 1 plus 10 is 11. Negative 1 plus negative 10 is negative 11. 2 plus 5 is 7. Negative 2 plus negative 5 equals negative 7. As we can see here, there are no pair of factors of 10 to get a sum of negative 6. In this case, we will say that this trinomial is non-factorable, and this will be our answer here. Let us put some notes here. We know that we are factoring a trinomial that is equal to two binomials, and that is x plus m times x plus n. If c is positive, the c here is the constant of our trinomial. It means to say the m and n. The m and n are here, should have the same sign. It can be both positive or both negative. Look at our previous examples 1 and 2. In example 1, the constant is 30 and positive. So look at our factors here. The 3 and 10 are both positive. Also, the sign of the b will tell us that the signs of the m and n should be both positive. Let's have example 2. The constant is positive 24. So look at our m and n. They have the same signs and both negative. Considering the sign of the b here, since it is negative, it gives us idea that these two binomials in the m and n should have both negative also. Now, if c is negative, the m and n should have different signs. Look at our example 3. Our constant here is negative 35. The values of m and n have different signs. One is positive, the other is negative. And there is another clause here. The bigger number between m and n should have same sign with b. So the numbers 5 and 7, 7 is bigger, and because the sign of the b is negative, the 7 as the bigger number will have the negative sign also. Hi everyone, today we're going to study factoring, and we're going to factor a trinomial of this form: ax squared plus bx plus c. How do we factor a trinomial of this form? We are going to follow some steps. Step 1 is factor any greatest common factor, or GCF. Step 2, find the product AC. This AC means the A, the coefficient of x squared, and the C, the constant of the trinomial. Step 3, we're going to find two numbers m and n, such that if we multiply the m and n, this is equal to the AC. This AC coming from step 2. Also, if we add the m and n, we can see it is m plus n. It must be equal to the b. And this b is the coefficient of the x in the middle term of the trinomial. Step 4, split the middle term using m and n. It means to say the ax squared plus bx plus c will become like this: ax squared plus mx plus nx plus c. Step 5, we're going to factor by grouping. Let us have example 1. Let us factor out 10x squared minus 55x plus 70. Step 1 says, let us factor any greatest common factor. For this trinomial, we can see that there is a common factor of 5. So we can factor out that number 5. So what remains in the first term will be 2x squared. For the second term, now becomes negative 11x. And the third term, 70, will become 14. Step 2, let us find the product AC. After removing the greatest common factor, we have now our new trinomial here to be 2x squared minus 11x plus 14. Now taking the AC, it means the A, which is the coefficient of x squared, it is 2, and the C is the constant 14. Now multiplying the A and C, 2 times 14 equals 28. In step 3, we're going to find two numbers that when we multiply these two numbers m and n, it must be equal to 28. But if we add the m and n, it must be equal to the b. And this b is the coefficient of the middle term of the trinomial. After considering many pairs of factors, it was found that the negative 4 and the negative 7, if we multiply, will be equal to 28. Also, if we add the negative 4 and the negative 7, it is equal to negative 11. So the 28 here is the product AC, and the negative 11 is the B. So step 4, we're going to split the middle term using m and n. It means to say, we're going to rewrite this trinomial but the middle term, we must split it using this m and n here. So as you see now, in this line, the 5 is copied. The 2x squared is copied down here. The negative 11x is now split into negative 4x and negative 7x. And then plus the constant 14. And in step 5, we're going to factor by grouping. So we have here 4 terms. We're going to group the first 2 and also the last 2. So the 2x squared minus 4x is now in one group. The negative 7x plus 14 is in another group. And using that factor by grouping, we are going to factor out a common factor or greatest common factor for these 2 terms. Also, we will do the same on the next group. So in here we can see that 2x is the GCF. So we put the 2x outside. What remains inside for this term will be x. And for the negative 4x, what remains is the negative 2. If we want to check if our factoring are correct, we can multiply 2x times x. We will get back the 2x squared, and then 2x times negative 2, we will get the negative 4x back. Now for the second group, we want this x to be positive, so we're going to factor out a negative 7. So when we factor out the negative 7, what remains here will be positive x. And for the positive 14, what remains is a negative 2. Again, just to check if these factors are correct, we can multiply and see if we can get the original binomial back. So the negative 7 times x is negative 7x, and negative 7 times the negative 2 is positive 14. So we are sure that these factors are correct. And now we have 2 big groups here, and we can see that there is a common factor for these 2 big groups, and that common is the binomial x minus 2. So we can factor that x minus 2 out. It will be like this. First, we copy the number 5. Now this common x minus 2 we'll put in here. And on the second factor, we will collect the remaining terms after removing the common factor. So 2x is copied here, and then the negative 7. So for our answer, the factors are 5 and x minus 2 and 2x minus 7. So this is our final answer. Let us have example 2. Factor out 6x squared plus 7x plus 2. Step 1 says, let us factor any GCF. But there is no GCF here. So we will proceed with step 2. We're going to find the product AC. The coefficient of x squared is the a, and that is 6. The constant 2, that is the c, we will multiply here. 6 times 2 equals 12. And then step 3, we're going to find 2 numbers, and these 2 numbers are factors of 12. And at the same time, if we add the 2 numbers, it must be equal to b, and that b is that number 7. After considering many pairs of factors, we found that 3 times 4 equals 12, and that is the AC, and 3 plus 4 equals 7, and that is the B. So now we're going to split this middle term using the M and N. So the 3 and the 4 are our M and N respectively. So writing this again, 6x squared is here. Instead of writing 7x, we will now write 3x plus 4x, and then plus the constant 2. Step 5, we are now to factor by grouping. We're going to group the first two terms and then group the last two terms. We're going to factor out the GCF for these two terms. We can see that 3x is common. So what remains in the first term, 6x squared, is 2x, and then plus 1. We can check if our factors are correct. 3x times 2x is 6x squared. 3x times 1 is positive 3x. For the second group, the common factor is 2. So we remove the number 2 outside. And what remains with the 4x is 2x. And then for the 2, it becomes 1. Again, let us check ourselves if the factors are correct. 2 times 2x is 4x. 2 times 1 is positive 2. So we are sure that these factors are correct. Now, we have two big groups here, and there is a common in these two big groups. And the common is that binomial 2x plus 1. There is also 2x plus 1 here. So we're going to factor out the 2x plus 1. It is now in here. And for the second factor, it is simply the remaining terms for each of the big groups. So the 3x is copied here, and then plus the 2. So our factors, 2x plus 1 times the 3x plus 2. Hi everyone, today we're going to study factoring. This time we're going to factor by grouping. How to factor by grouping? We're going to follow these 4 general steps. In step 1, we're going to group terms with common factors. Step 2, we will factor out the common factor in each group. Step 3, factor the common factor from the expression. Step 4, check by multiplying the factors. Let us have example 1. Let's factor out these 4 terms, xy plus y plus 2x plus 2. In step 1, we're going to group terms with common factors. So I'm going to group the first 2 terms, xy plus y, and the last 2 terms, 2x plus 2. In step 2, factor out the common factor in each group. In the first group, the variable y is common, so I'm going to factor it out. So y comes out. What remains inside is the x plus 1. For checking, I'm going to multiply this y to this x, so I will get back the xy, and then y times 1 is y. So I'm sure that this is a correct factors for the first group. In the second group, the common is the number 2. So I'm going to bring out that number 2, and what remains inside is the x plus 1. So checking again, 2 times x is 2x, 2 times 1 is 2. So I'm sure that this is a correct factors for the second group. In step 3, factor the common factor from the expression. We have now here 2 big groups. For each group, the common factor is the binomial x plus 1. So I'm going to bring out that common factor outside. So it is now x plus 1. Since we have 2 big groups, the second factor should be a binomial also. So I'm going to collect all the terms that will remain after removing the common factor from each group. So in here, it is y, and then plus the 2. In step 4, let us multiply the factors to check if our answer or if the factors are correct. So x multiplied by y, I will get that xy. X times 2, I will have this 2x. And then 1 times y, will get back that y. And 1 times 2 is 2. So these factors are the correct answer. Let us have example 2. 2x cubed minus x squared minus 10x plus 5. Step 1. Group terms with common factors. So I'm going to group the first 2 terms and group the last 2 terms. But you see here, our third term is negative. So while putting the grouping symbol, I should write here the plus and then put the last 2 terms in the grouping symbol. In step 2, factor out the common factor in each group. The common is the x squared. So I'm going to pull out the x squared. So what remains will be 2x minus 1. In the second group, the common is 5. But I should write negative 5 so that later the binomial here will come to be on the same value with the 2x minus 1 of the first group. So if I pull out the negative 5, what remains here is the 2x minus 1. Before going further, I must check myself if the factors are correct. The negative 5 multiplied by 2x, I will get the negative 10x back. The negative 5 times negative 1 is positive 5. So these factors are correct for the second group. And then for step 3, we will factor the common from the expression. So from the 2 big groups, the common factor is that binomial 2x minus 1. So I'm going to pull it out. So 2x minus 1 is now here. And for the second factor, I put 2 blanks because since I have binomials in here, I should have a binomial also in the second factor down here. And then to collect the remaining terms after removing the common factor from the group 1 here, x squared, I should copy down here. And for the second group, the negative 5. So for step 4, I'm going to check by multiplying the factors. So the 2x times x squared, the answer is the 2x cubed. 2x times negative 5, I will get the negative 10x. Then negative 1 times x squared, it is negative x squared. Negative 1 times negative 5 is positive 5. So we are now sure that our answer is correct. Let us have example 3. Factor out 2x minus 9y plus 18 minus xy. So let us group terms with common factors. If I group the 2x minus 9y, there is no common between these two terms. Also, the 18 minus xy, if I group these two, there is no common factors for these last two terms. So what I'm going to do is to rearrange the terms. I can put the 2x on the last part. So it's now negative 9y plus 18 minus xy plus 2x. And then from here, I can see now that there is a common factor in the first two terms. Also, there is common in the last two terms. So it's now the quantity negative 9y plus 18 plus. So again, I see here that the third term is negative xy. So I must be careful. I should put here the plus and put the grouping symbol for the negative xy plus 2x. And step 2, factor out the common factor. In the first group, the common factor is 9. But I want this variable y to be positive, so I should pull out negative 9. And if I do that, the remaining terms inside here should be y minus 2. Now, to check myself, the negative 9, if I multiply it by y, I will get back the negative 9y. The negative 9 times the negative 2 equals positive 18. So I'm sure that these factors are correct for the first group. Now, for the second group, I want that y to be positive also, so I should factor out a negative x. So what remains here now is positive y and then negative 2. So let us check again if the factors are correct. I'm going to multiply negative x by y. It will be negative xy. The negative x times negative 2 will be positive 2x. So I'm sure now that these factors are correct for the second group. And for step 3, let us factor the common factor from the expression. So the common is the y minus 2. It is now down here. And for the second factor here should be a binomial. I will simply collect the terms that will remain after removing the common factor. For the first group, the negative 9 will come here. For the second group, the negative x will remain, and I should copy that down here. And for the step 4, I should multiply the factors to check if it is correct. So y times negative 9, I will get the negative 9y. Then y times negative x, here is the negative xy. Negative 2 times negative 9, I will have this positive 18. Negative 2 times negative x will be positive 2x. So now I am sure that my factors here are correct. And this is our final answer. Let us have example 4. Factor out x squared minus 6x plus 9 minus y squared. Step 1. Group terms with common factors. If I group the first two terms, I can see that there is common between them, and that is x. However, if I'm going to group the last two terms, there is no common for these two. So this is a special case. It is possible that I can group the first three terms. So x squared minus 6x plus y is now taken as one group, and then the negative y squared will be alone. And then this trinomial, I can factor it out into the square of difference of two terms. Then I will just copy the negative y squared here. In step 2, I'm going to factor out using the special product difference of two squares, and this is the formula. When we have a squared minus b squared, the answer will be the binomial a plus b times the a minus b. In this case, the x minus 3 is considered to be the a, and the y is the b. So in applying this formula, it will be like this. So the a, the x minus 3, I will copy here. Then first I'm going to put the plus sign, and then the y. And then multiplied by the quantity x minus 3. This is the a again. And then this time should be minus, and the y. And then I'm going to simply remove the grouping symbol inside the square brackets. So the parenthesis inside is now removed. So these are the factors. So step 3, we're going to check by multiplying the factors if these are correct. So if I'm going to take one term each from this group and to multiply to the other group, this will be the product. So x times x will be x squared, x times negative 3 is negative 3x, x times negative y is negative xy. Next is negative 3 times x is negative 3x, negative 3 times negative 3 is positive 9, negative 3 times negative y is positive 3y. Now for the y, times x is positive xy. Then y times negative 3 equals negative 3y. And y times negative y equals negative y squared. And from here, let us see some terms that we can combine or cancel. This negative xy, there is a positive xy down here that we can cancel both of them. Also look at the positive 3y. There is a negative 3y in here, so both terms are cancelled. And then we will collect what will remain, the x squared. Then we have this negative 3x and negative 3x. Combining them, we'll get the negative 6x. We will copy the 9 and the negative y squared down here. So you see, the final answer here equals our original problem. So it means this trinomial and another trinomial here is our final answer. Hi everyone. Today we're going to do factoring. We will factor sum and difference of two cubes. And this is the form: x cubed plus or minus y cubed. First, let us review our special product when we multiply binomial times trinomial of this form. So x plus y times x squared minus xy plus y squared. The product is x cubed plus y cubed. Our product here is related to our binomial factor. It's like we take the first term of the binomial factor, put it here, and then put a power 3. And then the positive sign is copied here. The second term y is written here and then power 3. So let us analyze the trinomial factor. The first term of this trinomial factor is the square of x, and the x is actually the first term of our binomial factor. The y square is the square of y, and that y is the second term of our binomial factor. The middle term is the product of these two terms in the binomial factor, x times y. But on the pattern, we should write the opposite sign. So our special product here now is the sum of two cubes. Also, when we have the x minus y times x squared plus xy plus y squared, the answer is x cubed minus y cubed. And this is the difference of two perfect cubes. The pattern is the same. The binomial factor is related to our product. The first term x is placed on the product and with power 3, and then minus. Take note that our sign here is the same with our sign in our product, followed by the y is placed here and then with power 3. For the trinomial factor, the first term x squared comes when we square the first term x in here. The last term y squared comes from when we square the negative y. It will give us positive y squared. The middle term xy comes when we multiply the x times the negative y. We get a negative xy, but based on the pattern, we should write the opposite sign. So you see here in the middle, it is positive xy. For today's lesson, we will do the reverse process. The problem will come the sum of two cubes or the difference of two cubes, and you will be required to provide the factors of this form or of this form. How to factor sum or difference of two cubes? We are going to have these three steps. Step 1, write the terms as cubes. Step 2, use the sum or difference of cubes pattern. And the patterns are here. And step 3, simplify. Let us apply these steps to solve some problems. Let us have example 1. Factor x cubed plus 64. The steps are here. So we will apply the step 1 first. Write the terms as cubes. So x cubed here is now written as the cube of x, and then plus the 64 is equal to the cube of 4. And then step 2, we're going to write the factors. In the factors, we expect a binomial, times a trinomial. Let us write the binomial first. We will write the x, we will copy the positive sign, and we will copy the number 4. So our binomial is the x plus 4. For the trinomial, the first blank is the square of this x. So I write here the square of x. The last term is the square of the number 4, or the second term of the binomial. In the middle term, I am going to multiply the two terms here. So x times 4. But take note that we will use the opposite sign. So all the terms are now in place. We will just simply go to step 3 to simplify. I will copy the binomial, and then for the trinomial, I will simplify the square of x to be x squared. The middle term becomes negative 4x, and the 4 square is now written as 16. So this is our final answer. Let's have example 2. Factor 8x cubed minus 27y cubed. Let us first write the terms as cubes. The 8x cubed is now the cube of 2x, and then minus. The 27y cubed is now the cube of 3y. Step 2, we will write the factors. Again, in the factors, we expect binomial times trinomial. Let us begin with the binomial. I will now copy the 2x, and then the negative sign is copied here, followed by the second term, and that is the 3y. So our binomial is 2x minus 3y. For the trinomial, the first blank is reserved for the square of 2x. The last term is reserved for the square of this negative 3y. Look at the middle term. I am going to multiply the 2x and the negative 3y here, but later we should write the opposite sign. If I multiply a positive by a negative number, of course the sign will be negative. But based on the pattern, I should write the opposite sign. So going to step 3, I will now simplify. First, I copy down here the binomial factor. For the first term, the square of 2x is now 4x squared. For the middle term, I multiply the 2x times the negative 3y. It will be negative 6xy, but I should write the opposite sign. So this is plus. The square of negative 3y is now positive 9y squared. So this is our final answer. Let's have example 3. Factor negative 2x cubed y squared minus 16y raised to 5. We can observe that the terms are not perfect cubes. But remember, let us check for greatest common factor. I observe that the GCF is the negative 2y squared. So when I factor out the GCF, the first term becomes x cubed. The second term becomes positive 8y cubed. And from here, we can now apply our steps in factoring sum of two cubes. Let us write the terms as cubes. So first I copied the GCF, negative 2y squared, and then the x cube is now written here as the cube of x. For the 8y cube is now the cube of 2y. Now let us go to step 2. Let us write the factors. We expect binomial times trinomial. So in our binomial, let us now write the x followed by the positive sign followed by the 2y. So our binomial is x plus 2y. For the trinomial, the first term is the square of x. The last term is the square of this 2y. The middle term is the product of the two terms of the binomial factor, but we should write the opposite sign. So all the terms are now in place. We will now simplify. I copied first the GCF followed by the binomial factor. Let us simplify now our trinomial factor. The first term is now x squared. The middle term is now negative 2xy. And then plus the square of 2y is now 4y squared. So this is our final answer. I hope you learned something from this video. See you again next time.